Hello friend, welcome to my YouTube channel Electrical Boost. Today we are going to learn mesh analysis method. Okay. It is one of the method to simplify or analysis the complicated circuit. If you want to find some current and voltage within a complicated circuit, you can also use mesh analysis method. It is a method to analysis the complicated network. Okay, it is also called loop analysis. uh, it is a method where you use KVL plus Ohm's law. KVL 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 plus Ohm's law. Okay. uh, Previously you know what is KVL. KVL is algebraic sum of voltage is equal to 0 and Ohm's law is V equal to IR. Here we apply both combination of KVL and Ohm's law. Let's try with a circuit. This is a circuit. Okay. This is V1 source voltage, this is V2, this is RA, this is RB, and this is RC. Okay. Let we assume a current is flowing through like clockwise. This is I1 and this current is flowing like clockwise I2. Let assume we do not know where is the current to flow. Okay. Let assume current is moving clockwise. Okay. So that the polarity should be here plus minus, here plus minus for this current. If this current is flowing, this is plus minus. Okay. Plus minus. Okay. For this loop I1 is greater and for this loop I2 is greater. Okay. This is VA, this is VB, this is VC. Okay. Let apply KVL at loop 1. This is loop 1. We apply, this is minus V1 and this is plus VA plus here this is VB is equal to 0. Then apply Ohm's law in here. We know Ohm's law equal to I equal to V equal to IR. Here VA equal to, here VA current is flowing I1 into R1. Okay. Next VB, here is the interesting twist is there. VB is the voltage drop across RB. See here I1 is the current and I2 also current. Here I1 is entering and I2 is entering in opposite direction. So that here the current is I1 minus I2 because here we consider loop 1, so that I1 current is higher. Always higher current is subtracted by lower. I1 minus I2 into R2. Then we put in equation. Then final equation is minus V1 plus, we put V1 equal to I1 R1, then plus I1 minus I2 into R2 equal to 0. Then when you simplify this circuit, equation minus V1 equal to I1 R1 plus I1 R2 minus I2 R2 equal to 0. Then this is the equation number 1. Then another loop is there. So we apply KVL in loop 2. Apply KVL in loop 2. Okay. Apply KVL in loop 2. See here RB, this is plus because I2 is higher. Okay, plus VB plus VC plus V2 is equal to 0. Okay, then we apply Ohm's law. This is VB is equal to, here see, VB is equal to voltage across RB, here I2 and I1 current is flowing, but I2 minus, here I2 minus I1 into RB, because here we consider loop 2, so that I2 current is higher than I1. Okay, then plus VC equal to I2 into RC plus V2 equal to 0. Okay, then simplify. I2 RB minus I1 RB plus I2 RC plus V2 equal to 0. This is the second equation. Here we find this is the first equation and this is the second equation. After solving those two equations, we can find I1 and I2 and other element. Okay, after finding the I1 I2, then we decide RB current, VB potential is, if I1 is greater than, then VB potential is according to the I1. If I2 is greater than, then VB potential is according to the I2. Okay. In our next lecture, we discuss some another numerical type problem using mesh analysis. Okay. Thank you for watching this video.